All right, so for example 5, we're going to use the information we had in example 4 concerning the mean sales per month for the same computer game, but sold with 2 package designs. We want to make a test at the 1% level of significance, whether the data provides sufficient evidence to conclude that the mean sales per month of the 2 designs are different. And we're going to use the critical value approach. All right, so first, let's write our hypotheses. Okay, so we want for our null hypothesis to be that, and I'm going to call it mu1 instead of finding the mu symbol, mu1 minus mu2. If we subtract the 2 means of the 2 different design packages, we would expect no difference. That is our null hypothesis. It's the status quo. All right. Our alternate, however, we want to test and see if these 2 designs are different in either direction. So we want mu1 minus mu2 is not equal to 0. Let me look up my symbol here for not equal to. And there we go. Now, not equal to means it's a 2-tailed test. So we have that alpha, in this case, for a 1% level of significance, it's going to be 0.01, but it's a 2-tailed test. So we need to find alpha divided by 2. And if we divide alpha by 2, that's going to give us 0.005. Now we're going to look this up on our stat trek, but on our t-table, which means, again, we need our degrees of freedom. Now, we already found the degrees of freedom for this particular instance up above, and it was 15 degrees of freedom. All right, so we're going to look this up with 15 degrees of freedom. All right, so 0.005 with 15 degrees of freedom. Let me go ahead and find our stat trek. Still got the 15 degrees of freedom there, but we want to get rid of this t-score. And we want to get rid of this probability here, 0.005. All right, let's go ahead and calculate. And we get negative 2.947. All right, so let me go back. And so our critical value is negative 2. I lost it again. 947. Realize this is a 2-tailed test, so we also have positive 2.947. All right, so our critical region will be to the left of negative 2.947 and to the right of positive 2.947, the left and right tails of the bell curve. All right, but now let's do our calculations. We need to find our t-score, and we're going to use that horrible looking formula. Now, fortunately, in the last example, we did a lot of the work for this. We did x1 bar minus x2 bar right up here, and it was just 6. So we'll put on the top, we're going to have 6. D0 is the thing that we've got for our null hypothesis, which is 0, so it's just 0, divided by, there we go. Now, we did this calculation while doing our confidence interval, so let's find what that was. So, realize that was this stuff right here before I multiplied the t of alpha over 2n. So it really is this stuff right here in the parentheses, 5.771753. So 5.771753. All right, so we really have 6 divided by 5.771753. And I will do that in my calculator. I end up getting 1.040. All right. And if we compare this test statistic of 1.040 with our critical values. Remember what I said, if it's in the left tail, it's going to be less than negative 2.9, and if it's in the right tail, it's going to be greater than 2.947, and certainly this is in between. It's not in our rejection regions. So we fail to reject the null. All right, so let's make our conclusion statement. There is not enough evidence to reject the null hypothesis. It appears that the different design packages do not provide different sales amounts.